Precalc, Part B. We're just going to start this off with Chapter 7, Section 1. Here are your learning targets for this section, so you can follow along on your assignment sheet. Same thing, what's on there, but it has the things we'll try to cover for Section 1 right here. And this is all a review from Algebra 1, Algebra 2. We will make some of the problems a little more difficult, but we're just solving systems of equations. So let's see what we remember first. So if we have a system, and the system uses this bracket, which just means the word and. So the word and can be used with a symbol where you're tying two equations to describe one situation. So we can solve this using substitution. Now you should have done this in Part A of Precalc, a lot in Chapter 2 especially, but we can take what we know y is. Y is 3x minus 4, and we can put that in for y in the other equation. And that's the substitution portion. Now we could solve it for y if needed. So like you could like divide by 2, but to substitute we don't need to. So this would be 2 times 3x minus 4 equals negative 3x plus 10. So I wrote the second equation, but I replaced the y with what y is equal to from the first equation. So we can distribute. Then we can move the x's to one side, the constants to the other side, and divide to find our x value is 2. Now to find our y value, what we do is called back substituting. So we're going to take this answer for x and back substitute it into one of these two equations. And I would plug it in for this one because y is already isolated. So then y is going to equal 3 times our x value minus 4. So 6 minus 4 is 2. So then we know the answer for this is the point 2, 2. Another way to do this problem is to graph. And so we can actually take this first equation, y equals 3x minus 4, and plot that. So that's y equals mx plus b. It's amazing how many Precalc students have forgot to graph that. So down 4, our slope is 3, which is the same thing as 3 over 1. So up 3, right 1, up 3, right 1, 1. And we can draw a line between those. So here is that linear equation. We can do the same thing for the second equation here, but we may want to isolate it. So if I divide both sides by 2, I get y is negative 3 halves x plus 5. So now when I graph that, I go up to 5 for the y-intercept, and my rise over run is negative 3, right 2. So you can see that intersection. And so then we can draw that line. And you can see the intersection of the two lines is the solution to the system, which is still the point 2, 2. So let's review back from Algebra 1, really. So graphing, some overall content, graphing. You can graph each condition, which is the equation, and the points of intersection of the solution points of the system. Be sure to check those solutions and equations and make sure they all work. Steps of the calculator. You can solve each equation for y, because to put it into a calculator, it's got to have y isolated. We can graph each equation on the calculator. Then we can use the intersect feature. So on the calculator, it's under what it's calc, and then we intersect function is what you use on the calculator. It's the same spot you do like max and mins in the first try, but when you calculate, it's the intersection of the two graphs, and the calculator will find that for you. And so we can try this problem. I don't have the graphing calculator on the computer here, so I'll do it at school for you tomorrow. And so you see how this is a good one to use graphing calculator. So we started to do natural log, and so that's a little more complicated solving, so we can just use a calculator to help us out. We want to check for our solutions. We should realize that sometimes there's one intersection point, sometimes there's two intersection or multiple intersection points. So you can see how a parabola here, a quadratic, and a linear equation could intersect 0, 1, or 2 times. And then we have no intersection points here. That's another example. So be aware of the different kinds of solutions you may have. So substitution, and this is really what 7.1 is about, is substitution. We want to isolate one variable in terms of the other. So basically get a variable by itself. Then substitute, so you're going to isolate, then substitute the expression into the other equation. It's the other equation. You have to use both equations. You can't substitute something into the same equation. Solve for the variable, and then back substitute, and then check solutions. And so for this problem here, they're not isolated yet. They're not having a y equals or x equals. So I would take this top equation and I would actually isolate for x. Just add y. So x equals y, which is kind of nice. It says that they're equivalent values. So in the other equation, now I can substitute that in. So instead of writing x, I'm going to write y. Now notice here I'm actually going to solve for y, which is okay. Students a lot of times want to solve for x, so you're used to doing that, but you don't have to always solve for x. So if I just combine my terms here, 5y minus 3y is 2y, divide by 2, so y is 3. And we can back substitute, but we already know that x has to be the equivalent value, 3. So we can write that as a point 3. 3 is the actual solution, the intersection. And the whole point of this is that this point is the only point that makes both of those equations true. And that's what you're doing when you're solving systems. Okay, so this is more complicated. We have the x squared and y squared terms. So we're going to get more of these complicated systems in pre-calc. First thing, we're going to take the one that is a little more simple of an equation, and we're going to isolate one of the variables. Now if I isolated x, I would have to substitute it in twice. Not too crazy about that, more substitution. So I'm going to isolate y, so then I only have to substitute once. So my y value, 2x minus y equals negative 3, I'm actually going to add y to both sides first. That way it makes it positive, so I added the y. Then add 3, so 2x plus 3 equals y. So now that we know what y is, we can substitute that portion into the other equation for y. So 2x squared plus 4x minus y, which is 2x plus 3, the quantity squared, equals 0. It is very important that when you use substitution that you put parentheses around the portion you're substituting. That way you see that this square goes to the entire binomial. This negative has to be distributed through that as well. If you follow order of operations, something that a lot of students struggle with in Part A of pre-calc, so we first have to do the square. So that's going to be 4x squared. The last term is going to be 9. Our OI is going to be 6x and 6x, so that's going to be 12x. And then equals 0. So now we have to distribute the negative through there. So 2x squared plus 4x. Now I'm just going to change the sign of everything. Minus 4x squared minus 12x minus 9. I'll make sure everyone sees how you have to be very careful with your signs. Now we can combine the terms. We have a 2x squared minus 4x squared, which is negative 2x squared. We have a 4x minus 12x, so that's negative 8x. And we have minus 9 equals 0. Now to solve this, we need to look at factoring, quadratic formula, complete the square. I'm going to look at factoring, but first thing I would do is I would just change it, all the signs, and you can do that because we're really dividing by a negative is what we're doing in the equation. So this quadratic, if you try factoring if possible, this one's not factorable, so when we go to other techniques, I'll use completing the square here. So I'm going to first factor out 2 of just those first two terms. And then I can complete the square. Now I could, because I'm just solving, I'm not putting it into vertex form, I could subtract the 9 over there. So now, to complete the square, I want to add in here, half of 4 is 2, 2 squared is 4. So I added 4 to the side. This is not just 4, it's 2 times 4, so I need to actually, it's 8 to the side, I'm changing it, so I should add 8 to the other side. So we have 2 times the quantity of x plus 2 squared equals negative 1. Notice I factor that portion. I'm going to divide by 2, get negative 1/2. And you could do a different order. You could have divided by 2 first, and then you could have added the 4, and that would have also worked to give you the same value. So then we're going to square root both sides. So right here, now I kind of see something that's occurring. I have plus or minus the square root of negative 1 over 2. Right here I'm going to stop because of this. We have imaginary. That tells me that there is no solution. You could say the null set. You could cross through it. No solution for this problem. There's no intersection point. So the two shapes do not cross, and you may not recognize what this shape is. We'll do it later on in conic sections, but these two shapes will not intersect. And this is going to be hard to use the graphing because you actually have to isolate our y, which is much more complicated. So word problem here: a small company has an initial investment of $6,000. They have a product unit cost of $23.20 and selling price of $35.20. So they cost them $23.20 to buy that product or produce it, and then they can sell it for $35.20. How many units must be sold to break even? So we have two equations. It's a system, so you have at least two equations. For these problems, a lot of times there's two equations. There's a revenue equation that actually is like how much you're bringing in, and there's a cost, how much you're spending. So the cost one is you spent $6,000, so the cost is $6,000 plus it costs $23.20 for every item, we'll call it X, that you're going to be buying. The revenue, we get money for selling the $35.20 for those same things. And this is assuming that we're selling everything we're buying. What we want to know is when we'll break even. Break even is when our revenue is equal to our cost. And so we're just setting these two equal to each other. It's using substitution because this is C equals R when we break even. So I can take this entire chunk here and substitute it in for R. So 6,000 plus 2320x equals 3520x. So I'm going to divide or subtract the 2320 to both sides. So 6,000 equals 12x. 6,000 divided by 12 is 500. So we need 500 units to break even. Yeah, you can say hi to my students. Oh, here's my daughter. Say hi. What's your name?
Lucy.
Lucy. Okay, you gonna go play? Okay. Say bye.
Bye.
That was Lucy, one of the three. So we'll do these tomorrow in class. These are actually homework problems, and you'll see this in class as well when I do some problems in the lessons for Pre-Calc Part B. I've actually put homework problems in the lesson. So we're going to do these beginning of class kind of as review for 7.1 and getting into 7.2. So I'm going to have you try this one for a video problem. Video problems, here's how they work. I want you to try this, work it out on a scrap piece of paper. So I really don't care what you do it on, but when you walk in tomorrow, I want you to have this completed, and I want you to turn it into the input bin for your hour as soon as you walk in. I'm going to be looking at those, giving you a grade for those, and returning them back to you in class, kind of as a quick check to see if you understood the video and that you're able to complete some of these problems. So use a lot of your old algebra skills to solve this problem, but using substitution to solve the system. I'm going to call that good for the night. So that will be 7.1, and we'll see you tomorrow.